All right, so this is what we're going into next. It's just building on what we've already worked on. So it's not anything new. It's just the problem's a little bit bigger, a little bit harder. I'm going to put this example up here and show you what I'm talking about. 2x plus 4 equals 16. Okay, so obviously the difference is, our problems up to this point have been something like 2x equals 16. Okay, where we have one step. We divide by 2, x is 8. Well, this is what we would call a two-step problem. We have two things we need to do to solve for this problem. Okay, so I'm going to use different colors here to show you step by step what I mean. Now, we have to still, our goal is still to isolate the variables. So that's not changed. We're still going to have at the very end x equals something, or y equals something, or v equals something. That's still going to be the thing. That's why it's not a new material. It's just now the problems are longer. Now I have to get rid of this 4 and this 2. Okay? I have to get rid of both. Now, if let's say I wanted to get rid of this 2 and I go to divide by 2. The problem is I cannot just divide this part of it by 2 and then this whole side by 2. I've got to include everything in by dividing by 2. And sometimes, like let me put another one up there just to show you. We'll do this one. I know I'm jumping around, but I kind of want to hit all the areas of why we can't do the things, and why we have to do them in a certain order. Let's say I've got the same kind of problem, and let's say I say, okay, I go to divide by 5. I'd have to divide this whole side by 5, which means I'm going to have a fraction, an improper fraction. It's going to be very hard to work with that, because this will divide by 5, but this won't evenly. So we don't, and the reason why I did that is because this one you could divide by 2, and each one would work out, but it's not, a lot of times it's not going to be that way. So the first thing that I want to move, the easiest thing to move on this problem is this 4. Because if I have 2x plus 4 and I take away 4, that's easily to do. I can just subtract those and get my 0 and get rid of my 4. So in this case, my first easy thing to do is to get rid of the 4 by subtracting 4. Okay? You say, well, you're not doing that to both. I am. I'm doing it to the whole side. I'm adding 4, $4 or something, and then I'm taking away 4 from the whole thing. And then over here, I'm going to take away 4. And so that's going to cancel out. I have 2x. And over here, I have 12. Okay? That was my first step. So the 4 in this case is the easiest thing to move first. Then, now we're down to a one-step problem. I'm going to move this 2 by dividing by it. And I'm going to get x is 6. Okay? That's not going to be a good color, I don't think. But anyway, you probably see that one. Divide by 2, divide by 2. And I get x is 6. Okay? Now, you plug that back in. It's still true. 2 times 6 is 12, plus 4 is 16. Okay, so that will always be there. Let's do that one that I was saying, it gets harder that you can't divide right away. So that 5x minus 6 equals 9. Okay, here's what I'm talking about. If I go to divide by 5, okay, I can divide this, but this is going to be a fraction, and now I got to deal with fraction rules. But if I start by adding 6, okay, 5x equals 15, now all I have to do is divide by 5, and x is 3. I can plug it back in. 3 times 5 is 15. 15 minus 6 is 9. Okay? So that's, doing a two-step problem. You have to divide, you have to add, and that's a two-step problem, but you're solving just the same way. You're trying to isolate this variable. What about this, though? This is another example of a two-step problem. So x over 5 minus 3 equals 10. Okay. Now this one, you could, it's not as imperative, like you're not going to have fractions in the problem. And you could do any order on any problem. We're trying to find the easiest way. This way, now here's your two steps. You're going to have to add 3 at some point, and you're going to have to multiply by 5 at some point. Well, if you multiply by 5, you're having to multiply this whole side by 5, and you have to multiply this whole side by 5. That's fine, and it's actually easier than the division problem because you're not going to mess with fractions, but you're going to have some pretty big numbers, especially if these are big numbers. So to me, it's still just as easy, just like we did with the division ones. I'm sorry if you were copying that. Hopefully you're working in pencil. It's just as easy, just like we did with the division problems, to do this step first. Let's get rid of this 3. So it cancels out, okay, and you're left with 13 here. And then because you're working with less bigger numbers, you got rid of that. Now you don't have like a 15 or a 50 or something like that. Now you can multiply by your 5. Oops. Yeah, 65. Okay. So to me, when you have the option of adding or subtracting first, do that first as far as to move those things over, then do your division or multiplication at that point. We're not doing PEMDAS. This isn't like an order of one long problem. This is isolating a variable, so we're free to kind of do those things, you know, however, whichever easiest way to get rid of something. Let's do another one of those so you can practice that again. Let's do y plus 3, or I'm sorry, y over 3. And even when I'm talking to them, I'm getting ahead of myself. Plus 4 equals 12. So same thing. We're going to move the 4 first. Okay, so that we cancel it out, and we get y over 3 equals 8. And now all I have to do is multiply by my 3. I'm doing these in different colors so that you can see, because sometimes it looks like, you know, if I do it all in black, it's like which were steps. This was the first step, then multiplying by 3 was my second step. Okay, I can always plug this back in if you want to check your answers. 24 divided by 3 is 8. 8 plus 4 is 12. Now at that point, when you plug it back in, then you are doing PEMDAS, because you're working with all numbers at that point. Okay, so 24 divided by 3 first, 8 plus 4 is 12. Okay. Now, one more wrinkle to this, and let me put up that problem again that I started with the division, okay, and just show you the last little wrinkle with this. Okay, here's the one that we just did right before that one, x over 5 minus 3 equals 10. And I want to point out the difference of what happens when it looks like this. Let's do x plus 2 over 4 equals 7. So here again, we have you know, addition or subtraction thing going on and a division, but I want you to notice the difference. In this case, we started by moving the 3 because it was out on its own. It was not part of the fraction. And so we added 3 and then we multiplied by 5. In this case, you can't do it that way. Hopefully you can see the difference, how the problems even look different. For one, the main difference is this addition or subtraction is put up top now. Okay, once it's on top of the fraction, part of the fraction, you can't just subtract 2 out here and not include this 4. The 4 is a part of this too. So at that point, you're working with fractions, and we avoid that. Okay, it makes them a lot harder. There's a lot of, now sometimes you can't. Sometimes fractions are part of the problem. Not really what we're going to be doing, but as you go on in math, you know, you can't always avoid it, but if we can, we are. And so in this case, you're really left with one choice as far as to make it really easy, and that is we can't just move the 2 by subtracting it because it's got this, it's actually 2 4s. So we'd have to move it as a fraction. We're going to start by getting rid of the 4. Instead of dividing by 4, we're going to multiply by 4. So what happens is, just like if this had been just x over 4 equals 7 and we multiplied by 4, you know, and that was the one-step problem, just like we did that, and those cancel out. It's the same principle here. These cancel out. We're left with just what's on top. Like in this case, we were left with just on top. And over here we get 28. The only difference is now, this one we were done, but this one we still have to get rid of our 2. So we're going to subtract our 2, and we're going to get x is 26. Okay, plug it back in. 26 plus 2 is 28. 28 divided by, 26 plus 2 is 28. 28 divided by 4 is 7. Okay, so that's the last little wrinkle, is what happens when the addition or subtraction is on the fraction. I say last little wrinkle. There's one more thing I'm going to put up there. Let's do another one of those, though. Let's do x minus 3 over 5 equals 7. Okay, now in that point, okay, once again, it looks different. See, the x minus 3, I didn't think I planned it that way. But see how these are different. It's almost the same. You got x minus 3 and then you got it over 5. The difference is this is part of the fraction now. So what you have to do is you have to multiply by 5. Okay. Instead of starting out with adding 3, because it's part of that fraction. That'd be 3/5. We don't want to mess with the fraction. And then the last step that you can do is add 3. And x is 38. Okay, plug it back in. 38 minus 3 is 35. 35 divided by 5 is 7. Okay, so that's doing all the different kinds of two-step. The one last one I want to put up there is if in case this happens where you have 5 minus 2x equals 7, where these have been flipped in place-wise, well, you still don't want to divide the whole thing by 2 first, because you're going to have 5 halves and it's going to be a fraction. You can still move this 5, okay, and it cancels out. Just be cautious, just be aware that now this is a negative 2x, this negative is here. And so when you go to divide, make sure you divide by a negative 2. So the full thing, we did these, but the full thing cancels out, and in this case you get negative 1. Okay? So don't necessarily throw out your negative rules just because we now are two-step. Okay? So let me put your examples up there, your assignment, and have you work these. Okay? 1 is 3x minus 3 equals 9. 2 is 4x plus 7 equals 27. Number 3 is 7 minus 2x is 15. 4 is x over 3 plus 2 equals 7. Now this is one where it's not part of the fraction, so move it first. Okay? Y over 5 minus 3 equals 12. Y plus 3, all on top of the fraction, so keep that in mind, equals 10. And number 7 is x minus 7 over 2 equals 5. Okay? All right, try those 7 problems. We covered all this. Work with that, okay?